Assalamu alaikum students. We continue unit number 3 with second law of log, which is known as law of quotient or law of ratios. It allows us to convert the problem of division into the simple problem of difference. So how we can do this? We learn with the example, but first we prove that law of ratios in the law of quotient. So let's prove it. To start the proof, we have to let these two parts equal to two different variables. We let log m to the base a is equal to x and log n to the base a is equal to y. We name this equation as 1 and this one as 2 for reference. As you observe, these are logarithmic form. These are logarithmic forms. So we can transform them into exponential form according to the definition of log. So we write these equations in exponential form. We have base remains base and equal value become power, and that value, the log of the number, it becomes equal value. For equation 2, base remains base, y will become power and n will become equal value. We name these equations as equation 3 and equation 4 for reference. As we observe that we have m and n in the right hand side and they have a relation in the requirement, that is they are in a ratio, they are in a division form, m divided by n. So it means if we divide m by n, so we have to divide the equation 3 by equation 4. By dividing equation 3 by 4, we have a raised to power x divided by a raised to power y, and that is equal to m divided by n. If we observe that we have same bases in the left hand side in a ratio, so we apply the law of quotient of power with same base. The y is taken to the numerator and hence we have a raised to power x minus y. So applying law of quotient of power with same base on left hand side. We have a raised to power x minus y is equal to m over n. As this is an exponential equation, so we can transform into logarithmic form according to the definition of log. So by writing in log form, we have log base will remain base, equal value will become the value of the log m over n, and the power, the exponent will become equal value x minus y. We have the values of x and y in equation 1 and 2. So we put these values in this equation. We have log m over n to the base a is equal to log m to the base a minus log n to the base a. Hence it is proved. Now we learn how this law of ratio convert the complicated problem of division into the simple problem of difference. Let's learn with the help of an example. We take two numbers in a division form and let that they are equal to variable x, and these two numbers are 291.3 and that is divided by 42.36. If we use calculator, so we have the answer 6.877. And now we check that how log will help us to obtain this. Nowadays we have calculators to find the result of such problems. But in old days, the calculator is not present. So therefore, these calculations becomes far more difficult when the numbers becomes larger and larger. So hence, these log tables as well as these laws will help a lot in that regard, as these laws make the problems easy. Now take log of both sides. We have log x equal to log 291.3 divided by 42.36. According to the second law, we observe that the ratio of m and n is simply transformed into the difference of two distinct logs. So here we have a ratio with log. So we apply the second law of log. We have log 291.3 minus log 42.36. We take the values of log by using calculator and we have 2.4643 for 291.3 and 1.6269 for log 42.36. We find the difference of these two and we have 0.8374. Now we have the value of log x, and by taking antilog, using antilog of this, we have x is equal to antilog 0.8374, and using calculator by pressing shift log function and putting the value of 0.8374, we get 6.877, and that is the same value which we get by the division process. But again, I recall you that the old days, the calculator is not there to help them to find such the difficult calculations of division, as this division takes many steps and it will take you a lot of time in those days. So therefore, log tables and these laws are invented to help out the mathematician and the scientist to do such difficult calculations in short period of time. Thank you.